Thank you for the confirmation. Uh, yeah, so I would like to welcome you on behalf of Pioneer Business Solutions and Pioneer Business, and I would like to welcome warm welcome to all and even trainer also. We have trainer Rajiv Chandran with us. I would like to uh, welcome you all with behalf of Pioneer Business Solution. And before diving into the webinar, I'm sorry for the glitches we had to start this webinar a bit late. So I'm sorry for that. And before dive into the webinar, I would like to take a quick few minutes of your time to introduction about our organization, what we do, what we do. And yeah, Pioneer Business Solution is a fast-growing, leading corporate training industry, and with a decade of experience and delivering quality learning solution to organization across the globe. And we are also present physically and virtually across the globe. And we also support a wide range of learning needs across various domains like technical, functional, and even OEM trainings and certification programs. And our approach is to like proactively, we tailor a solution to meet customer expectation and deliver high impact solution and training expected experiences, and with global and presence of physical and virtual. And we have a very successful stories with us, and we are also very known in the market for all the niche technologies. And we also have 1500 trainer with us who is uh, who is already like who is already tie up with us, and they are available for a next complete in a year, 3 months in a year. And we are not only onto the training sector, and we also like support on corporate training, information technology, mechanical and civil engineering services, cloud services, and HR services. And these are delivery modes that we support, like ILT, VILT, and hybrid learning, e-learning, open house sessions, and mentor on demands. And these are the authorized partner which we are authorized with a third party like Microsoft, Scrum Alliance, and Scale Agile framework and project management. And this is all of our offering. So we also support campus to corporate competence development training, project consulting on soft skill and the development programs. So this is not only for the freshers level, the soft skill, it's from the L1 to till the CEO levels. We also cater. And we also cater various segments of campus corporate, as I mentioned, like how to handle the freshers from the like college to campus. And these all the major trainings modules which we support, and this is all soft skill competences which we support. And this is all the technical trainings, as we are already delivering many of the pipeline webinars we have, and data science and technical requirements will support. And this is we have internal resources like trainer. We deployed into our client location 7 trainers we have, and we do have a exclusive contractor trainer 300 plus, and freelancer trainer with subject matter expertise we have 1500. So these all are trained and certified trainer. And we have very unique selling point, I can say. So we do support the solution, and we do cater all the requirements based on the client expectation within 4 to 24 hours of time. So this is all our client which we are working on day in day out, and this is the client list. And this is all about us. And once again, thank you all. And I would like to welcome Rajiv Chandran. He is a seasoned technology leader trainer, and he's having nearly two decades of experience. And he also core expertised in data engineering, machine learning, and generative AI, cloud technology, DevOps practices. And he's very large languages module, and even very niche topics he will be handling. And this is all about Rajiv. So I just given one quick intro. Thank you. And this is all about today webinar. So once again, I would like to welcome Rajiv and even participants also for attending this webinar. And today agenda is and key takeaway like AI and Gen AI, the future is now, and LLM, real world use cases and foundation models, and GPT transformer, and building your first Gen AI apps. And these are overview the about the webinar. So I would like to thank you all. Over to you, Rajan. Thank you.
Yeah, thank you, Sugandhi. And welcome all to this session. Yeah, you have been delayed though. Apologies on that. How we can get started right away? I need to share this screen, Sugandhi, just to. Okay, yeah. So I hope you are able to see my screen and I'm audible. Uh, yeah. Thank you for that acknowledgement. Otherwise, extending a warm welcome to this session on uh, AI, basically, but specific focus on understanding what's generative AI and that technology stack called large language model. We will look at this particular subject from the perspective of understanding what it is and how you could build a career around it, as well as how would you apply these stacks in the softwares that we are building. That's larger. That's the larger context. I'll go through a set of slides, understanding what it is, and towards the end, I'll also show you a small little demo, which would help you visualize how effective and how effective this particular solution is. Okay, so artificial intelligence, right? Now, this is a subject which has been, ideated over many centuries, many years. Sorry, let me. Yeah, many centuries or many years by many civilizations as such. And the early attempt, sorry, just a second. Yeah. So the early attempt the early attempt to understand this came from the use cases of trying to develop machines, trying to develop machines that can do probably mathematical uh, workloads. So that was the early attempt. There were many such tools that were developed over a period of time, uh, eventually with the evolution of computers. So, uh, but when we use the word artificial intelligence, what we were looking, I don't know whether this was the original idea, but at least since the last 50, 70 years, or probably 70 years early, 40 onwards, early 40 onwards, during that World War, the idea got, from that more crystallized, and there were very clear understanding of what this term AI represents. And simply put, it was to emulate your human brain on a metal, and rather make a machine uh, do everything that a human does from an intellectual perspective, not from a physical or a mechanical perspective, which there were machines definitely was evolved at that time to some extent, and now it's in a very great extent. Right, so having it from intellectual perspective was the target. So uh, so artificial is a technology that enables machines to simulate a human reasoning and also problem solving. Okay, sorry, just a second. Sorry, just a second. This is okay. So that's the understanding of word artificial intelligence. Now, how it differs in from a today's context is all the machines that were developed or evolved were largely to crunch numbers. There were no other. There weren't a machine that would actually that would be involved with playing with text. Playing with text was, I mean, or processing. When I say processing text, pretty much like how you would process numbers, where that would involve, any of these mathematical concepts of addition, subtraction, division, exponential, and things like that. That was not possible with your uh, texts that were generated, and texts were generated by every society, uh, much like English, and we have, I mean, what, maybe 15,000 or even 20,000 different languages, dialects that, and each of these language have the way to produce some text, right? So that wasn't processed much like how you would do a numerical process. Okay, so having said that, having put that context, be I mean, they were able to kind of analyze, they were able to kind of categorize artificial intelligence, keeping in mind that they wanted to emulate the brain within a machine. They categorize that as artificial narrow intelligence, artificial general intelligence, and super intelligence. Okay. Uh, when you so if you now when you say that you are trying to simulate a human reasoning or problem solving ability, your human brain processes both text uh, and a number, right? It processes both. Computers prior to this processed only numbers, or calculators only process numbers, but it is the first time that you had a machine that was processing both numeral and text, much like what a human was doing. So artificial intelligence therefore encompassed learning it was an amalgamation of different subjects, like machine learning, which is purely playing with numerals, language processing, which was uh, which was which was all about processing with your text, with characters. That's what it meant. And then processing this in a very particular way, much like how a human would do, and that was what we called as deep learning. So artificial intelligence therefore encompasses all these different process on a machine, literally emulating a human mind. And rather, yeah, I mean, it's basically, we have vision, voice, though touch, touch, taste, and smell. Though they can be emulated, but they are presently part not of it. It's basically your voice and vision from the those five senses point of perspective. And when you look at the categories, the narrow intelligence is something that existed for quite some time. It's not that it just came up in the early 2000s. You are pretty much aware of the processes like facial recognition, or image processing, which you do in a Photoshop and things like that. So those were all early stages of AI, and that's why we call it narrow intelligence. Okay. And then what we are attempting to do, and we are pretty much close there but not reached, is pretty much process like how a human does with voice, images, and numbers. Right. So that's that's what we are. I mean, it's just not about processing that. It's like, so when you ask this question, why is the sky blue? You will have to go through multiple different experiments to come up with that. When you do experiments, that means you will have to evolve some processes, some mathematical side of it, some physics in that, right? And understanding these properties, and then finally you will you are able to conclude that the sky is blue because the light is kind of spreads across because of water, maybe the particles and things like that. Now, to come to such a conclusion, it probably takes years of research and thing. So it is now, can a machine behave in that context? That's what we are kind of reaching on to. But we haven't reached there. And then super intelligence, I mean, it's pretty much like uh, what a human itself is, whether uh, uh, whether you can really create something beyond what a human, but there's no clear definition. But they have still given this idea of super intelligence, maybe pretty much because of fascination of aliens and things like that. That may be a only reason. However, this is there, and we are attempting to be here. Okay, so now understanding this idea called machine learning, deep learning, and what is this neural network about? The If you if you take this whole AI stuff at a pretty high level, this is still data analytics, but a data analytics done in a different way. Uh, so it's been nearly what, 400 or even probably I think 400 or 500 years since this evolution of this word called statistics. I'm sure pretty all of you all are aware of this word. The idea of statistics, where you are given a set of data and then you come up with some conclusion by doing some process like mean and various other forms, standard deviations, etc. And I'm sure a lot of you all have heard of this word called bell curve and things like that, right? And when a data is in the form of a bell curve, what does that mean, etc. So this particular stuff has been there since 400 500 years, and added to this was this concept called probability. So we had statistics, which was all about processing to derive some conclusion from the set of data. Example, like, yes, if I take Bangalore city and then I want to calculate the average salary, how would you do it? Now, there are two ways to look at it. You can take a sample of the salaries in particular region, spread across Bangalore, and you can do an average, but that average probably may not be that realistic. So what they do is they analyze the data through a probabilistic structure. So when you do this, what happens is you get a inferential value of it. So you would say, much like you've seen these election statistics that shows in the thing, saying that, hey, you are expected to get so many seats, and there will be deviation of plus or minus, things like that. Okay. So when you look at it from that perspective, statistics and probability is the base of anything in AI. That's the core. There's nothing beyond it. And when you looked up, so these statistics and probability later evolved into uh, using other algorithms, mathematical equations, I must say, to solve this idea of prediction. Okay. And then starts this idea of different formulas being evolved for predicting, and that's what we use the idea of machine learning. So machine learning means you use your data to predict, just like your weather or your sales, etc. But when you had statistics and probability, it only gave you the as is state at that point in time. It never went into the future. Okay, so that's how the things changed. Okay, so machine learning, there's a whole set of formulas that you use to predict the future. Now, what happens is when this machine learning, they weren't that accurate, because that's how, by the nature of the way the nature the way the data gets generated, that's how it has been. But uh, with this idea of neural network, what happened is this machine learning formulas, when applied via a neural network is basically that data which you collect and you represent it in a very specific form which appears like your neural network. And then when you do apply your machine learning formulas on that particular data, you are pretty much arriving at uh, accuracy of 99% or so. And the proof of it is, if you have used ChatGPT, and if you look at the images that are generated there, they are realistic images, and it does not seem to be represent. I mean, it does not seem to appear like as if it's a drawn. It is very, very close to how it would appear if you have taken a photograph and things like that. But they are mathematically generated. So you are able to do that when you applied your machine learning, and when the data was represented on your neural network. So so that actually evolves this whole idea of getting close to this artificial general intelligence. And then to see the the present state, if you see where you are getting to even better human, I mean, the realistic stuff being the realism being even better than human human perception. That's because this neural network has further evolved into this idea called deep learning architectures. It is a deep learning is again a neural architecture, but when you represent that in that deep learning form, you are getting absolutely perfect answers, which is even beating what even human accuracy is. Example, when you look at an image, there can be some level of fuzziness, some level of a confusion, or a probability whether okay this could be whether it could be that image or not. But the neural networks seem to be even beating human accuracy. If a human is 95%, these are able to beat that to nearly 99%. So machines have actually beaten humans in a lot of few things, especially with this vision and kind of stuff. And deep learning has played a major role in that. Okay, so that's one side. As I told you, while we've all been learning about how to create, about how to work with numbers to solve your problem, and that seems to be very pretty intuitive. But we've never learned how to really process uh, uh, words and sentences and derive a meaning. So you are able to quite read this evolution of models in natural language. I mean, you are pretty much reading it and you're making sense of it as you read, right? So first thing on this idea of natural language processing, it has two sides to it: natural language understanding and natural language generation. So what it means is, if you read something, you understand, and then if you want to expand on it, you generate. Uh, Now, the computers prior to, let's say, 2018 really didn't do this stuff, or even if they did, it just didn't make sense. Uh, so uh, what we have achieved in this idea of generative AI is evolution of these natural language processing to meet a human level quality in terms of understanding and generation. So if you look from here, it started with the attempt with a speech recognition, or rather translation, which like everybody nearly wants. If you are in a world stage and different languages coming, you want to do some level of translation, understand or summarize it, and you may want to do some mining, some sentiment analysis, text generation, or in a text, if you have some entities, let's say example, okay, that text talked about a table and chair, so we have to can this algorithm spot and say, hey, that is talking about a table and a chair, or it's talking about a car, human, mountain, rivers, etc., named entity recognition, and that's what it means. So yeah, these are all these things were never part of any algorithm earlier. Uh, that's what generative AI did, through their algorithms. Okay, so now I talked so much about how we are able to process um, how we are able to process text, um, much like how you would process numeral. However, it's quite obvious. I can't take these two words and add them up, right? It is very obvious. You don't need a rocket science to understand that. Uh, but however, this concept called word embedding is doing exactly that. What it does is, if you take this paragraph, word embedding is a numerical representation. Now, words such as how colors can be represented using RGB. We want computers to read text as humans do. We need embeddings that capture the semantic and syntactic information. This whole paragraph, uh, with each of the word, I can put a number there. Every word can therefore, so that means we are right now conversing in English. Take any of our languages, any of our languages, uh, all of it can be uh, represented as a numeral. So that means if you take, let's take this, I mean, take an Indian word like, what do you say, maybe karma. If you take that word, and karma can be represented, be it in Kannada, Hindi, Sanskrit, of course, Sanskrit, or any other Indian language. Now that value for that numeral, uh, for the word karma, be it in English or be it in any of Indian languages, uh, would have a value, a numerical value. And that is what word embedding does. So prior to word embedding, so that word embedding starts uh, around 2013. That was the first real attempt to get it going in a big way. Prior to that, there were various forms of trying to get a numerical representation of the word. Like color is represented as it shows you. Color is represented by some number, which you are also familiar if you are using Photoshops and things like. You can also have a word representing with some neural. Okay, so this was the old traditional way of doing it, and these are all statistical method. But starting 2013, I was I I mean, rather, the world was managing to have a very accurate representation of these numbers with that word, and it starts around thing, and there are multiple ways of doing it. This was the first attempt, and this is the second attempt, and we'll come into that. Okay, so once I could transform, or rather, not transform, represent, I should say. We are not transforming, we are able to represent words, not characters. Like I'm sure you are aware of ASCII characters and things like that, but this is not that. That this number, like when you create a sentence is created with some syntaxes, correct, and with some semantics, and because there should be a meaning of that, isn't it? So there is there is a structure and there is a meaning. So each word must have the meaning and the syntax when it is represented by a number. That's word embeddings. Okay, so generative AI is all about uh, working much like what humans do with text or images or videos or any other representation of data. Uh, generative AI did not exist prior to 2017. There was no such idea. In the sense, at least from a computer. But however, you pretty much know that I could, an artist, could generate any forms, correct? I mean, you can take an artist can take any object and represent it in various form, but that he does it uh, mechanically. I mean, through his mind and pen, isn't it? But not a machine doing it arithmetically. That's generative AI. So generative AI evolves from deep learning, but what did it do mainly is it was able to play with text, and that changed everything, and that's why we see a lot of. However, you should remember, generative AI is not just about text. It's about text. It's about voice. It's about vision. And if we had a way to codify your sense of touch and smell, even that can be evolved into various of these ways. Okay, so as I told you, there is this idea of traditional AI, or it just comes from I mean, it just you get traditional AI as as a retrospective effect because there is generative AI. So what is your traditional AI? Things like this facial recognition, fingerprint stuff, or predictive analytics. So all these now falls under as a retrospective effect into a traditional AI. Then what's generative AI? Generative AI is all about creating content, understanding, autonomousity of anything, like cars and something which goes autonomous. They are all part of generative AI. Okay, that's how we segregate it. Okay, so foundational model. So what's this idea of foundational model? The algorithm that is able to do generative AI is what we call as foundational model. And why we are calling it foundational model, we'll come into that. Okay, so foundational models are nothing but again deep learning algorithms. mm, and how they are different is that these algorithms are trained on large set of data, and this data can be text, voice, images, video. It could be anything, but it's trained on large corpus of data. And by making it train on such a large corpus of data, uh, this this algorithm, basically it's a data structure, DSA, data structure and algorithm. It's a combination of that, starts behaving much like our human brain does. It's able to process, just like how you understand while reading some text. This algorithm is able to understand. It can generate. Yes, it can take autonomous decisions, much like you do, and summarize. You name it. It can do a lot of things that way. And That's what we call foundation model. And foundation model also has own categorization. It started with large language models. So this foundation models are the first, which I'm sure you have all heard of, Chat GPT, and that is the original foundational model. It's not that others have not created, but that's the first model. And it's an yeah, it started, I mean, it's developed grounds up. So you have large foundational model. Just like foundation model can process text, we also see that foundation model are also built for vision, audio, and it can be combined for probably vision and text, or vision and audio, and you call them multimodal by nature. Okay, so that's your foundation model. That's the base. If you have a foundation model, then you are in a position to really tackle problems. A machine can tackle problems much like how humans do. Okay, and so there is again this idea of LLM. LLM comes, large language model, comes from the idea of these foundation models. And why we call it large language model? See, language models existed uh, prior to 2013. I told you, like 2013 is a cutoff time. Prior 2013, it used statistical process to do language translation or any other process for working with an NLP. They were all language models. They were never large. But when you created this tool called foundational model, uh, it was a very, very large model. When I say large model, that means it's like trained with billions of text. And that's why we call it a large language model, indicating that this is not contrasting it with the language model that existed in the statistical era. Okay, so what's transformer? Um, uh, and this idea called self-attention. That algorithm, which is the core of a language model, mm, or a large language model, or rather, better word is the core algorithm and the data structure, which represents a foundational model, is your transformer. Okay, so transformer is that tool, is that algorithm which helped you to generate data, or if you look at from that NLP slide that I showed, it can do natural language understanding and it can do natural language generation. Okay, so transformers will do that. And transformers will do it for text, which was the first invention was for text, and then later it went for vision, and then audio. It probably it stands at at this point. It stands for all these three. I'm not sure whether it's there for a sense of, I mean, touch, smell, and taste, and things like that. But at least this is there. This is the core technology stack which did it. And this was actually done at Google and by an Indian guy. I mean, rather, he led the team developing this core technology. Okay, so what happens next is from this transformer, um, there were two technology stacks that were created. Um, just going back, sorry, let me, I thought, yeah. So uh, the core the core technology for generative AI is um this tool called transformer, right? And it was never invented for data generation. It was actually invented for language translation. But from that idea, when it was open sourced by this, when it was open source, the transformer was open source. Google developed what is this tool called BERT. BERT was uh, the core use transformer, which is the brain, and other set of algorithms for you to do sentiment analysis and other language understanding processes, summarization, named entity recognition. Google built this tool. Google built that particular tool. Parallelly, there was this effort by this company today, which you are all aware of, called OpenAI. They took a different track. BERT was NLU, natural language understanding, but BERT was developed again at Google, and some of these guys left and started this tool called a company called OpenAI, and they developed a tool called GPT. Hmm? GPT. They developed a tool called GPT. Now, how it differed? The transformer. I could use transformer for understanding or for generation. GPT did it for generating text. So these two are those pioneering efforts which led to that famous application which is called Chat GPT. And Chat GPT internally is nothing but GPT-2, and then everything gets evolved around that, and that comes around that time of 2000. That's where when this whole the whole revolution starts on this stuff. So just to give you a context on what I was trying to. So that's transformer, and now you understand the idea of GPT. So GPT is something that evolves from transformer to generate. GPT does both. It is while it does it primarily worked on generating the original GPT for generating text, but the GPT-2 combined the qualities of BERT and GPT to both generate and understand the thing. So generative pre-trained transformer is nothing but a foundational model where it can do both generation, and it's basically a foundation model which will do both of it. And this is truly the large language model that we are actually talking of. Okay, so what are the use cases of maybe the other term is foundational model or large language model? And what are the use cases? I mean, it's we have reached a stage where, yeah, I mean, you can ask a question, where is that I can't apply, and there is really no answer to that. It can be applied everywhere. Everywhere, it's having a little brains kept inside your house, into your office, inside a software, inside a machine. There is no place that it can be. It can be, and it can be at any activity that a machine or a human does. You can augment that effort through a large language model, and it's reached that stage. So so if I take like customers, you can have an absolute virtual conversation, and you won't even realize the conversation that you're doing is with a AI agent and not a human agent. It's reached that level, right? It can create music, it can generate art, images. Uh, uh, this year's Nobel Prize for physics and chemistry was given to two computer scientists because I'm sure you have heard about these that about algorithms that today can play chess and various other things, isn't it? That form of algorithms, which are slightly different from the foundation model, I should say. mm, a foundation model, I should say. But you are able to combine this foundation model and that particular kind of algorithms, and you are actually coming up with algorithms that can invent new mathematical stuffs. uh, uh, it can answer, or probably at some point in time, it can tell you that the light behaves like a wave, and as a particle. uh, it, 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 it can, with the data collected, it can probably tell you how the universe is, right? It's to that level. And it's already been used in protein discoveries, vaccine and development of new vaccines, development of new mathematical formulas, which was otherwise all it was just purely exclusive to human creativity, right? You are able to do all of these kind of things, and not to forget the whole business operations. Okay, now that we understood tech stack, we understood some use cases. Now, what is in it for you? What do you want to do with this learning, or why are you in attending this, and what's your gain, or what are you going to understand out of this? Now, that's what we're going to see in the next step. How can you, as probably a data analyst, use generative AI? How I can, as a developer, use generative AI, or how I, as a content writer, or a marketing executive, or a salesperson, mm, or you take uh, any of any of job roles that you are aware of. Can I use this, and how do you really develop it? That's what we are going to see. So developing applications with generative AI, and that's one of the biggest today industry ask. And if you look around, this is the most sought after job today, in the industry, because everybody wants to be in it. Okay, so how do we do this? Now let's take a classic case of HR applications. Okay, uh, many of y'all may be working in some organization, and every organization that exists will have an HR, right? Without which HR and sales and things, these are the mandatory pillars of an organization, right? Finance and things like that. So now let's take about the HR role. And every HR comes out with whole set of documents which include policies of various nature, and they give you handouts, or they would share it through web, and there are various ways, right? uh, Now the problem here is, all these are given, and it's quite obvious that you are not going to really read through everything of it, because it's so much of a content. Much like when you take a medical, when you take an insurance of any sort, that terms and conditions are so vast, that either you have no time to read through. I mean, you really don't have time to read through, or any read through, you don't make a sense. That's why you may you take you leverage any of the lawyers to get all these things done. If this particular data were to be exposed to a generative AI, and I can ask generative AI, can you tell me a company's top three policies? Or can you tell me how is the path for progression? Hmm? What are the other benefits? So instead of going through these hundreds of documents, your generative AI is able to go and pick up those important pieces, much like how you would read policies when in need, right? So that is one a fundamental area that you can start with, where it is basically a search, but that search is a generative search. It's a basically generative AI driven search. Now, how do you build a solution like that, right? Do you really need to know those whole things about transformer architecture and etc. to do? Not really. But you should know how to consume these large language models, much like I'm sure a lot of you all may be using chat gpt. So even if you're aware of that level, then you can start building applications for your different use cases. So you learn how to do, you select a use case, then you would need to select that right foundational model. And you saw there are various kinds of foundational model, right? You learn how to select the right foundational model, and then you build your solutions around it. So this is the area where there are maximum requirements than about building a foundation model itself. So the large Indian services uh, industry is looking towards uh, skills to build such a things for their various clients that they have. Okay, so now when you step into this world, you will have to start looking at. See, there are multiple foundational models. Some are open source, some are not. Like ChatGPT is not no more open source, but whatever Facebook does, they release everything under open source. Microsoft releases all their things in the open source, and the whole set of Chinese companies, organizations do that. Some are partly open or and partly like Google is. So there are hundreds of foundational models that have evolved in the last 3 years, to be more specific. After Chat GPT was evolved, so you should know how to pick a foundational model that solves a problem. Now, if a foundational model mm, can't solve a problem, then you should know how to do this idea of fine tuning. Example, um, if you take your foundational model and you as and you in your organization and you're selling some products, right? Uh, and if you ask some question about the product that you're selling, say like in Chat GPT, uh, Chat GPT will not know because it has never been fed with that data. So, a very classic case in 2023, any model that came out in 2023, and there are a lot of them. If you were to ask who is the Prime Minister of India, they very clearly know it. The model, but you ask who's the President of US, and these models exist even now, right? You ask in 2025, you query a model which was developed in 2023, say late 2023, ask who's the Prime Minister of India, they very clearly know it. You ask who's the president of US, now it will tell that it's Biden because it's never updated. So all models you should know have a cutoff date. And that's why so there is a way to make it updated with all the latest data. So but you should remember they are never updated with with the latest data, and our model will never contain all the data. It won't contain data, say, of Indian legal system. It will not contain. So that means you create you go to ChatGPT and try to create a rental agreement, uh, which, as per the Indian laws, it can't do it. So you will have to train on that. Or even you go to ChatGPT and ask certain things which are related with probably Ayurveda. It won't be able to, but general medicine it may be. Okay, so always models can't be built with everything, while you can always train your model to be very domain specific. Okay, so that's something you should be aware of. And then, yes, so once you know how to pick your model and prep the model to solve your problem, and then you are able to build up your application. Now, this whole life cycle of learning how to take it, how to choose, how to prep, and then build your application. This is what we generally call as Gen AI developers. Where you in a situation like this, you also need to bit understand uh, AI, but not that deep level, but to some extent you need to understand Gen AI. Okay, so this very specific ask, retrieval, augment, generate, fine tuning, and prompt engineering. Now, this is the set of skills that you need to build a Gen AI app. If you learn how to do this, then you can very safely use the word I am an AI engineer. Okay, very safely you can use the word I'm an AI engineer. So what do you mean by the word called AI engineer? You are able to bring in artificial intelligence into probably the app that you're developing, or maybe externally you apply, but you can embed a foundational model into whatever that product that you have. And so, I mean, do remember, it's just not about embedding it only in app. When you find ads which says that my refrigerator is AI enabled, my washing machines are AI enabled, and TVs have been always been smart. Now this is AI smart. Okay, so your mobiles, I mean, not to forget, can be AI phones. So this can be embedded in multiple different ways, right? So the application is just I mean, it's kind of unlimited. It seems wherever there is a human touch and there's a human process, it seems to be that you can just embed your AI in that. And all that you need is this stuff. But of course, getting into embedding in mobile and your refrigerators and washing machines and things like that would need to have a core large language model developer skills. And that gets into it. But that piece of job is what? Just 20% of the whole ecosystem. This is what largely covers the major part of it. Okay, so what's prompt engineering? So prompt engineering is pretty much what you do in front of your chat GPT. You pose a query to the model and try to get the answers. Okay, and there are different styles of posing the question. That's your prompt engineering, and then you will have to be very creative on how you're going to pose a question. It is much like doing an interview. If you want to know whether that candidate uh, is uh, is skilled enough to be in your organization, you need to pose those right questions for him or her to. You need to pose the right questions so that based on the responses that you get from from the candidate, you are able to analyze it. That the individual can be selected. It could be just a single question, a multiple question, or a series of questions. There are ways of doing it, and that's called prompt engineering. Okay, so retrieve, augment, and generate. This is a technology stack, mm, that helps you to make your large language model, make your large language model uh, with the relevant data that it's missing, or bring it up to the latest data. As I told you, there is a cutoff date on which the models are built. So if it is not, I can use this stack to make your um, uh, a large language model with the latest set of data. So like example, now large language models will not have the Indian legal data, and this legal data keeps changing a period of time, right? So if and you want to keep it up to date with all the latest stuff. So a model can't be doing that unless and otherwise you keep training the model. And I'm sure many of may be aware of, training model is a very expensive proposition. Right? It's not a cheap thing. It runs into millions. Of course, there are other ways of doing it, but even then, those are also running into tens of thousands of USDs that we are talking of. Okay, so fine tuning is that technique where you take a large language model or a foundational model and prep that model to do domain specific tasks. Example, like I told you, you can take a Meta model or a Facebook's model and train it to handle the Indian legal data, because presently there's no models on that. You really don't build models on there. Likewise, you can build a model which would cater to coding. You may build model which is catering to something else. So this process uh, of prepping the model to some domain specific task is what we call fine tuning. And this is one large part of activity every organization does, because as I told you on that whole HR stuff, if you ask the chat GPT model and ask it, uh, give it uh, give uh, uh, give me your organization's give your organization's top 4 HR policies. Chat GPT can't, right? It is never designed for that. So you will have to add this your policy into the thing for it to be given, and that's fine too. Okay, so developing an application, much like any other stuffs, also requires application frameworks. So I've just only put 2 here. There are actually many frameworks, many frameworks that exist 2030 at this point in time. But these 2 are the two leading frameworks to build your Gen AI apps. And you need it. And this app development is actually called RAG itself. Okay, that retrieval, augment, and generate. And this is the tool that you're going to use. Okay, so I talked about that you always need to keep your large language model up to date. And the way to do that is using you get the latest data and store it in what is called as a vector database. This is slightly different from other databases that you are others aware of. And you use your vector databases to store those additional data which your large language model does not have. And the interesting part of this vector database is that it can store all kinds of data, structured data, semi-structured data, unstructured data, etc. Okay, so that's the other interesting aspect of it. Okay, so largely today, the organizations are building your solutions using you can't really avoid a cloud in at this point in time. Everybody is using one of these set of tools uh, to uh, to build your applications, and largely it's through AWS Bedrock framework, Azure OpenAI framework, and Google Vertex. And of course, you also have OpenAI to build your app. But you need some platform to build, and you can choose any one of this to develop expertise and build your solutions around it. Okay, bigger organizations get into a hybrid mode while they use, because of the cost, it's very expensive, right? Overall, while cloud, the public cloud gives you the best of all choices that you can get, but it's expensive. So some people have it in hybrid mode where they also do something in local and also consume something in the private and in public, sorry. So they would actually build up something. So a lot of financial organizations do this because they don't allow any data to be hosted outside their, I mean, there are a lot of data that they can't allow it to be hosted outside their premises. So they do that, and while they may still take the services of the public. Okay, so presently this is the ecosystem. There are a lot of foundational models, a lot of cloud players in it, a lot of hardware providers. It's one massive stuff that's going around there, as and equally an opportunity for the organizations to improve, while it also generates a lot of employment. Of course, there are a few areas it get impacted as well. But always do remember, a new technology, uh, net, it only generates more than it probably reduces in a very short term. Okay. Okay. So that's about it. That I had to speak on this particular on this webinar. And let me see if I can just quickly show you a small little demo. Uh, okay, and let me reshare my screen for it. Okay, hope this screen is visible. What I have here is, okay, so I have a small database. It's an SQLite database. And it has all these uh, tables in that, different, pretty much normal employee and HR database. I mean, HR app, I presume. It has all of this thing, okay. And if you want to do some analysis in with this by the HR people, the I mean the HR employees, yeah, now though not part of their requirement, but they don't have a choice, and unless and otherwise, you learn SQL to do their queries, and right, it takes its own time to learn any of these things. But look how Gen AI helps you in this. Okay, let me just import this quickly. Um, okay, it looks like it's been imported, and I'm using your Chat GPT to solve my problem. Now, what I have simplified is, I want to know which employee has the highest salary. Of course, I can't ask a database a question like this, which employee has, but I can ask my generative AI with a query like this. And let's see the answer to it. Hmm. Okay, it seems to have queried that. And what is the question, which is the highest salary? And it outputs this employee as the person with the highest salary. So I'm sure you've noticed the simplification. What's simplified here? Look at the amount of uh, you know effort that is needed to machines are supposed to be doing that, reducing their effort to just answer this query. Okay. So I hope you understand the power of Gen AI. And these are the kind of problems that you solve with Gen AI. With that, yeah, I pretty much conclude my session. Yeah, I'm sorry. Yeah. Yeah, Sugandhi, you can take over from here.
Yeah, sure. Thank you, Rajiv. Thank you all for attending this webinar. And we have posted the feedback link in the chat box. I request all the participants to give your valuable feedbacks. And if any issues, you can scan the QR code and give your feedbacks. And once again, special thanks to Rajiv for sharing this knowledge to the participants. It will be helpful. And shortly, we'll come back with other slots and other webinars on AI and other topics. And I request all the participants before leaving the session, give your valuable feedbacks on this. Yeah, thank you all.
Okay.